Yes? Yes, Stephen? Yes, Narobega? Please, let's connect your microphone, please. Connect your microphone, please. Yes, Mary. Mary?
Yes, teacher.
Narobega,
Yes, teacher.
today your audio is not good. What has happened? Are you using what are you using? A phone or what?
A laptop.
A laptop. Have you eaten? Today you sound so low. You have not eaten.
I ate.
You ate, eh?
Yeah.
Hey, talk with energy. Talk with energy, huh? Talk like a woman now. Talk like a woman with a lot of energy.
Okay.
Uh-huh. Are we together?
Yes, teacher.
You have understood how this formula came about, right?
Yes.
Uh-huh. I said, just a reminder, I said in dimension, we cannot get the constant k. If you want to find a constant k, then we use what we call mathematical analysis. But dimensionally, we just use to derive the equation. Okay? Are you together?
Yes.
Uh-huh. Now let's look at some unit past papers which I've already put for you even in the notes. Like when you look at that question there, let's look at this question together. Let's go to number 3, question number 3. That was in 1999. Some of you were not even yet there. Yes, let's look at that question. They're saying the viscous force F on a small sphere of radius A falling through a liquid of coefficient of viscosity Na. That symbol is called Na. Okay? That symbol is called what? Na. Okay? Are you seeing that symbol? Yes, that symbol is called Na. With a velocity V given by, here now they have made it very simple for you. They have given you the formula. So just a matter of getting the what? Just a matter of getting the powers, the value of X, Y, and Z. So we have F is equals to K. Then we have A to the power X, Na to the power Y, then V to the power Z, Now they're saying use the method of dimension to find the value of X, Y, and Z. So they want us to find the values of X, Y, and Z, but using what? Using dimensions. Now members, for us to answer this question better, there are some few things we need to put them first into perspective. And one of them is Na, okay? Which is coefficient of viscosity. Okay? So we come and say it, but coefficient of viscosity, coefficient of viscosity is a ratio, okay? Is a ratio of force to cross-sectional area and multiplied by what? So coefficient of viscosity is equals to force divided by area time velocity gradient. Takes note of that. So we are saying Na is equals to force divided by area time velocity gradient. We shall look at this one in details when it's still under mechanics. We shall look at that one when we come to fluid mechanics. Okay? We shall discuss that one at length when we are looking at fluid mechanics. But for the interest of time, let's just know that coefficient of viscosity is equals to force applied divided by area time velocity gradient. Because when you look at a fluid, coefficient of viscosity, because viscosity is the friction, okay? It's a frictional force exerted for fluid. That is for, when I talk of fluid, I'm meaning gas and liquid. I'm meaning gas and liquid. That's a combination of these two, okay? Fluid is anything, is any substance that can flow. So we can see that gas can flow, or air can flow, liquid can also flow. So we shall look at that one when we are looking at fluid mechanics. That one we shall discuss it at length. Okay, but for now, we shall say coefficient of viscosity is equal to force over area time cross-sectional area. Take that one into consideration. Now, so since we know what coefficient of viscosity is given by A, they have told us is radius, A is radius, then V is velocity. I think the rest are okay. The rest are okay because now they are straightforward. So now the next thing is to find dimensions. We get dimension of each of them. So we go to dimensions. So we get dimension of the force F. Dimension of the force F must be equal to the dimension of the constant K time dimension of A, but to the power X, time the dimension of coefficient of viscosity, which is to the power Y. Then we also get dimension of velocity, which is to the power Z, But we know that what's the dimension of force? What's the dimension of force? Members, what's the dimension of force?
It's m L to the power negative 2.
Is it M?
L to the power negative 2.
Negative 2. Good. Equals to, what's the dimension of a constant?
1.
That one is 1. We don't need to write it. A is radius. They told us A is radius. Radius, when you measure radius, that's the length, not so?
Yes.
So, which means a dimension will still be what?
L.
L. But to the power? To
X.
the power X. Then, I think to make our work look easier, let's first get the dimension of coefficient, okay?
Yes.
So let's first get the coefficient of that. Let's first get the dimension of that. So dimension of nga, okay? Dimension of nga will be equals to, from the formula which we said force over area. So which means we have to find the force, dimension of force, divide by dimension of what? Area time velocity gradient. The fact still remain is velocity. Velocity gradient is still velocity, okay?
Yes.
Yes. So when we talk of velocity gradient, velocity gradient, let's write it. Velocity gradient. Gradient means there's a change. Gradient means there's a what? A change in the velocity, but over length. Are you together?
Yes.
So we shall say, like you can say what I've put up. So we shall say velocity gradient is going to be change in velocity. Change in what?
Velocity over length.
Change in velocity over what?
Length.
Over length. That is velocity gradient. Because gradient means there's change. Right together. So if that one is true, so we know that change in velocity, we can put in maybe from moving from velocity what? We can say V2 minus V what? V1. Just for the purpose of understanding, okay? Over dimension of length. But we know that the fact this is change in velocity. When you're subtracting something, what you get is still get velocity, right? So the fact that remains this is still velocity. So which means if it's still velocity, which means we're going to write dimension of velocity, and velocity is given by, what's the dimension of velocity? Is L T to the power negative what? Negative 1. Velocity negative 1. Velocity is negative 1. Okay. Divide by length, which is it? Which is what? L. You find that now L will cancel out with L. I think that. Then you remain with T to the power negative what? T to the power negative 1. That is for velocity gradient. because force, we can get it, area, we can get it. So velocity gradient is where we need to write some formula first. So velocity gradient, we get t to the power -1. Now we come back here. We come back here. So we shall say, nga, dimension of nga, which we said is force, dimension of force, divided by dimension of area, time, dimension of velocity, dimension of velocity, what? Gradient. So we shall have, for force we have, force is m, not so?
Yes.
ml t to the power negative what?
Negative.
-2 over, what's the dimension of area? Area is L square, not so?
Yes.
Area is L square, time, velocity gradient we just got is what? Velocity gradient we got what?
T to the power -1.
-1. Now using our indices, let's simplify this one further. So you find this L will reduce this L, right? Then we remain with M. This L now will reduce this. So we remain with M, T negative what? -2 over L to the power T to the power -1. I think that this L has reduced this L, okay? Members, have you seen that?
Yes.
Now, when I take this thing, when I take all of them up, so when I take all of them up, so it becomes, so shall have M T to the power -2 time. Now remember, when I take this one up, the power will become positive because I'm getting the reciprocal of this, right? So this one, the power becomes, so it becomes T to the power 1. Then L, because I'm getting this reciprocal, the power here is positive. So when I get this reciprocal, the power becomes negative. Negative. Very good. So if we simplify that, we shall have M. When you look at L, we shall have L to the power negative what? 1. Then T. T here we have 2 of them. So negative 2. Negative 2 plus 1 will give us negative
1.
-1. So that's the dimension of viscosity. That's the dimension of viscosity only. Okay?
Yes.
Yes. So this is the dimension of viscosity. Now we go back to our, we go back. Where we said from here is here. From the formula that I've given us, okay? From F equals to KAX na to the power Y, then V to the power Z. Like I've said, we are going to get dimension of each of them. So dimension of F is equals to dimension of K time dimension of A to the power, X time na to the power Y, then V to the power Z. So for force, what's the dimension of force? Is M L to the power -2 equals to, this is a constant, dimension of a constant we know is 1, right? That one is 1. So we remain with area, this is radius, which is L, so L to the power X, L to the power X, then into dimension of viscosity we got M L to the power -1, T to the power -1, but to the power Y. Then for velocity, what is for velocity? What's the dimension of velocity? Is L T to the power negative what?
T to the power -1.
But to the power what? Z. Okay? So using the distributive property, now we shall have M L T to the power -2 equals to, so let's put L together. I have L, let's start with L. L here, we have L to the power X, right? So which means we shall have X. There's also
X
L here. So
minus
Y, right? Not so. Then there's also another one here. So it becomes plus Z.
Plus.
Not so.
Yes.
We move to the next one, M. I have M here. M is to the power
Y.
To the power y. Is that m anywhere here? There's no m now, right? We go to t. I have t here, but t here is to the
Negative
power negative y.
Minus
Z.
Minus z. Very good. Good. So we have that. Now the next step is equating what?
the powers.
Equating powers. So dimension, let's start with dimension of m. Dimension of m. This m is the same as to the power what? What's the power here?
Power
0.
1.
The power was 0.
That's
Who
the
is it?
one.
The power is 1. Sandra, that one must be Sandra. Sandra, the power is what?
It is 1.
Is a 1. So 1 equals to m here is what? Is it?
Y.
Is y. So is that any m anywhere? So therefore our y is what? Our y is 1. We move to the next one. We move to the next one. Dimension of
L.
Dimension of L. So when you look at L, in the left we have to the power
1.
1 equals to what about in the right in the right hand side? We have
X
x
minus Y
minus
plus
y
Z.
plus z. So therefore we shall have x minus y plus z equals to 1. So this one our equation number. That is our equation number 1. Sandra, let me tell this one to Sandra now specifically. I know Sandra is now. We write it like this, okay? Someone may ask, why are we leaving it like this? We said whenever you are solving any equation, the unknown must be in the left-hand side. 1 can never be equals to x minus y plus z. 1 will never be equals to that. But the unknown must be equals to something. Okay?
Yes.
Yeah, you cannot tell me 2 is equals to x. That one is wrong. This one is wrong. Mathematically is wrong. Okay? 2 cannot be equals to x, but x can be equals to
2.
Yes, take note of that. That's why I'm readjusting this equation to make it like that. Okay?
Yes.
Now we go to the which dimension? We go to dimension t. Okay? For t, what do we have in the left? For t, what do we have in the left? If you are following me,
Negative 2.
Negative 2 equals to what is it in the right?
Negative y minus z.
Negative y minus z. Good. Negative. So when you look at this equation, so it becomes negative y minus z equals to negative what? Negative 2. But members, we have already got the value of y. Not so, which means we can get z from here. Not so? So if I make z the subject, so we shall have negative y plus 2 equals to z. Am I wrong if I write like that? Am I wrong?
Yes.
What should I write it? Z.
You should write
2 minus y.
2 minus y. Good. So z is equals to 2 minus, what is the value of y? What did we get? What was the value of y?
1. Y equals 1.
Y is 1, so minus 1. So therefore, our z is also
1.
Our z is also 1. Okay? Are you together, members?
Yes.
Have we answered all the questions? We have got y and z. What is remaining? X, not so?
x.
From which equation is that? From equation number? From equation 1. What is the equation? X? What is the equation, please? People, you have started dozing. X minus y plus z equals to? Is equals to what?
Equal to 1.
Good. That's what I want. I don't want people to be dozing when I'm not seeing you from here. Okay, we are looking for x, so let's make x the subject. So we shall have x equals to 1 plus y minus
z.
minus z. So x is equals to 1 plus our y, which is also 1 minus 1. Okay?
Yes.
So what is x?
1.
Hmm?
It is 1.
Sandra,
Yes, teacher.
is it not 2? Sandra may
No.
say it's 2. Nalobega, is it not 2? Mary is now quiet. It's only Sandra and team who are participating. Stephen, what are you doing? Mary, are you with us?
Yes.
Or you are still cooking?
No.
Oh, you know, some of you are very funny. You attend the lesson while cooking also because of technology. Sandra, Nalobeka, what have you got?
1.
Okay, I thought maybe you have got 2. Okay, now if we have got all the unknowns, we have got all the powers. Now we put them back into our formulas, which was F is equals to K A to the power X, N to the power Y, then V to the power Z. So we put them back. So therefore, our formula now will become, our equation become F equals to K, A, the power is 1, right? Then N, which is for Y, we also got what? 1. Then V is also what? But now when you write to the power 1, that one shows that you have not been attending lessons. Okay? When you write again to the power 1, we said any number raised to power 1 is that number. So there's no need of again writing the power 1. Okay? So that's it. Therefore, our F is equals to K, A, N, then V. So that's the formula I want. As simple as?
That.
As simple as that. Okay? Members, are we together?
Yes.
That's how simple it is. That's how simple it is. I think you people, you are very good. I think you can do for me this one. I think this is up to of 2005. Or we do it together first. You name of 2005. Are you seeing this question here?
Yes.
Yes.
We do it together.
Yes.
You hear them. You hear them. Okay, let's go through it together. But this time you are the one going to tell me what to write. I want to see whether you have been following me very well. Otim, you take us through that question. Otim, just read for us the question. Read the question. Read the question.
Okay. The equation for the volume V of a liquid flowing through a pipe.
We have volume V, right?
Volume. Yes. Flowing through a pipe in time T.
Time T. So we have time T.
And a steady flow is given by V over T equals to
is what?
That
is pi.
Pi R to power 4. P over 8 L. 8 L. L.
L.
Where
what is
R? R is the radius of the pipe. P is pressure difference between the two ends. L is the length of the pipe. N is coefficients of viscosity of the liquid.
The question is saying?
The question is saying, show that the equation is consistent.
Members, the question is asking what? Show that they are dimensionally consistent. Here we are not deriving the equation. Are you together? I see the difference now.
Yes.
Here we are what? We are applying the first concept that we have learned how to use dimension to show the validity of equation. And how do we show that the equation is valid? By making sure that the equation is dimensionally consistent. Okay?
Yes.
And we say that equation is dimensionally consistent if the dimension on the left is equals to the dimension on the right.
Right.
Okay? So the dimension in the left hand side must be equals to the dimension in the right hand what?
Side.
In the right hand side. And that's when we shall conclude that a given equation is dimensionally consistent. Are you together, members?
Yes.
So let's start by considering what?
The left hand side.
Considering the left hand side.
Side.
In the left hand side, we have
Volume over
volume over what?
over time.
Over time. So we shall say dimension of the left hand side, okay? Are you together?
Yes.
Is equals to dimension of what? Volume over dimension of what?
Time.
Over dimension of time. Mary, what's the dimension of volume? Mary, what's the dimension of volume? Now, Rebecca, what's the dimension of volume?
L cube.
Good. L cube. Out of, what's the dimension of time? Sandra, what's the dimension of time?
T.
Small t. I write small t.
No, capital T.
Okay. So which means the dimension in the left hand side become L cube t to the power
-1.
-1. So that's the dimension of in the left hand side. We are through with that, not so?
Yes.
Also considering what?
The right hand side.
The right hand side. In the right hand side, we have pi r to the power 4 p over 8, okay? 8 nga, okay? L.
Yes.
So there are so many things there, okay?
Yes.
So dimension of this. So dimension of that will be equals to dimension of pi, okay? Are you together?
Yes.
Dimension of pi, then dimension of what? R to the power 4, okay? Then dimension of p divided by dimension of 8, okay?
Yes.
Time dimension of nga time dimension of what?
L.
Of L. So what's the dimension of pi? Pi is a constant. So dimension of a constant is it?
1.
1. R, radius is length. So dimension become what? L.
L.
L to the power. What did we get? I remember we work out dimension for pressure. What did we get? Dimension for pressure, force over area. What did we get? Let me show you from here for the interest of time. Where is it? Pressure. I think pressure here, I think that. Huh?
Yes.
Yes, it's force over what?
Force over area.
So when you substitute for force and area, you get M. You get what? M. Okay? ml to the power -1, t to the power -2. Are you together?
Yes.
8 is a constant, so that one is 1. Viscosity, we have just got it. What did we get? What was the dimension of viscosity?
ml power -1, t to power -1.
Is what?
ml to power -1, then t to power -1.
Is it this one, eh? Is this one?
No, I said no. I said ml power -1, and then t to power -1.
T to the power -1. Like that, right?
Yes.
This one is not there. Then for length is what? Is L. So we have, let me write it here again so that you can see it clearly, so that we remain consistent. Members, I'm sorry, our time is running out. Our time is running out. So we have L to the power 4 times M, L to the power -1, T to the power -2, divided by M, L -1, T -1, L, right? That's what we have, right? Let's work it out. I have L here, I have L to the power 4, I have L to the power -1. What it will reduce to what? L to the power
3.
To the power 3. Not so?
Yes.
M is alone, so M. T is also alone. Okay? Over here we have M. I'm seeing L here is to the power -1, L here L is to the power +1. What does it give us?
0.
It will give us
to the power 0.
L to the power 0, which is 1, not so?
Yes.
Let's just write it for the purpose of consistency. L to the power -1. So this one will give us L to the power 3. We find that this M will go away with this M, right?
Yes.
This one will also remain 1. So we remain with T to the power -2 times. Now, when I take this one up, it become positive. So it becomes T to the power what? +1. Right?
Yes.
So when we have it like that, so we shall have L cubed, -2, -1. What does it give us? Negative what?
-1.
-1. So this is the dimension of the right hand side. So when you see the left and the right, are they the same?
Yes.
Okay. So you come and say since the dimension of the left hand side is equals to dimension in the right hand side, therefore the equation is dimensionally, what? What were they saying in the equation? Consistent or correct?
Consistent.
In the equation was called, yes, consistent.
Consistent.
Is consistent. Okay? Members, I think we are together on that. We know how to derive equation and we know how to check the consistency of a given equation, right?
Yes.
Is there any question on those two areas? Members, is there any question on those two areas on how to check for validity of equation and how to prove, how to derive a formula? Is there any question on that?
No.
There's no question, right? Now, when you look at, I think this question here, this one. This one of 1997, you have already done it. Do you remember that? You have already done this. Not so?
Yes.
This one you have already done it. So you are not going to repeat it. You are not going to repeat it. Do for me any question that we have not done. Any question that we have not done. Okay?
Yes.
So you have this UNEP of 2010. UNEP of 2010. Go and work it out. Or can we work out this one of 2010 together? This one of 2010. Members?
Yes.
I believe you know what, because in 2010 there's something I want to show there, because when you look at for 2009, the rest they are clear. They are clear. But here we have what we call young modulars. You know, you remember young modulars, no son?
Yes.
Young modulars is what?
Ratio of strain to stress.
Is it? Stress?
I think ratio of strain to stress.
Young modulars E is stress over what?
Strain.
Over strain. So you have to, if you want to get dimension of young modulars, you get dimension of stress divided by dimension of
strain.
strain. But we said, remember, we said stress is the same as what? Stress is the ratio of force to cross-sectional area, right? Yes. So I think you work out that one. That one is your exercise. You never
What of strain? What of strain?
Strain
Yes,
strain is extension, okay? Okay? Over original length. Okay? Now when it comes to dimension, extension is still length. I think that extension is still what?
Length.
You are still measuring length, so it becomes L. Okay? Original length is also what? Length. Not so?
Yes.
You find this and cross out, so we remain with nothing. You remain with 1. And remember, when we are talking about dimensionless quantity, do you remember that? Dimensionless quantities. Do you remember that? And strain was one of them, right?
Yes.
Which other one? Relative densities. Okay? Relative density is the dimensionless quantities. Refractive index. I think that. All these are quantities without dimension because they are ratios of the same quantities. Are we together? Members, are we together?
Yes.
So work out for me this exercise of 2010. Write down the question. Have you written down the question? I believe many of you have downloaded this book. This book is already on the website. Have you downloaded it?
No, we don't have it.
Okay, you write the question very fast. Write the question. I'm saying that the velocity of a wave in a material of Young modulus E and density is given by V equals to the square root of E out of Young density rho. Okay?
Yes.
Yes. Prove for me that that equation is dimensionally correct. Okay? Members? Hello?
Yes.
I need the answer before sunset also. The answer before sunset. Okay?
Yes.
By the way, when should we do a test? I feel like giving a test. When should we do it? Sandra, you are saying something, but I'm not getting you. Sandra. Hello? When should we do a test? Sandra has gone. Nalubega? Mary? When should we do a test? I feel like giving a test. I just feel like, when should I give you? Because we have finished one topic, dimension.
I think
over this weekend, I'm giving this weekend. I will send, after sending this work, I will get to know your WhatsApp number. Then I will share the question with you on WhatsApp number, on your WhatsApp number. Okay? Okay?
What are you saying?
I'm saying over this weekend, I will give a test. Okay?
Okay.
Yes, over this weekend, tomorrow. I'm going to give it tomorrow. But I will send it to you, direct to your WhatsApp number. Okay?
Yes.
Okay?
Yes.
How will I get to know your WhatsApp number after submitting this work I've given? Once you submit this work, I will be able to see your WhatsApp number, and then I forward the question to you.
Okay, this number which you have left us with.
Yes, the other one you used the other time. Okay?
Yes.
For those who don't have, use this one. The number is here. The number is there, okay? And all of you must submit the work. I saw you are 4.